Suppose the limit as n approaches infinity of the absolute value of the quotient of a sub n plus 1 and a sub n equals 1. Find the radius of convergence for the given power series. We have the sum from n equals 1 to infinity of the product of a sub n, negative 1 to the power of n, and x to the power of n, all divided by 3 to the power of n. Because of the x to the power of n, which we could think of as the nth power of x minus 0, the given power series is centered at x equals 0. And now referring to the notes on the right, when we have a power series in the form of a sub n times the nth power of x minus c, the x values for which the power series converges is the interval of convergence. Since the series diverges for x values such that the absolute value of x minus c is greater than r, the length of the interval of convergence is 2r, and r is called the radius of convergence. If a series converges only at x equals c where it's centered, r equals 0. If a series converges for all values of x, we say r equals infinity. Let's determine the interval of convergence using the ratio test. Because the given formula uses a sub n, let's let b sub n equal the given formula, and now determine b sub n plus 1 by replacing n with n plus 1. And now set up the limit, which in our case will be the limit as n approaches infinity of the absolute value of the quotient of b sub n plus 1 and b sub n. And now let's write this quotient of quotients as a product of quotients. We can do this by multiplying by the reciprocal of the fraction in the denominator. And because of the absolute value, we can also eliminate negative 1 to the power of n plus 1, as well as negative 1 to the power of n. This limit equals the limit as n approaches infinity of the absolute value of this quotient. And now let's begin to simplify. Let's focus on the base of 3. Notice we have n factors of 3 in the numerator and n plus 1 factors of 3 in the denominator. We have one more factor of 3 in the denominator, and therefore 3 to the power of n divided by 3 to the power of n plus 1 simplifies to 1/3. And now looking at the bases of x to the power of n plus 1 divided by x to the power of n simplifies to 1 factor of x, which would be in the numerator. This indicates we can write the given limit as the limit as n approaches infinity of the product of the absolute value of the quotient of a sub n plus 1 and a sub n, and 1/3 and the absolute value of x. If we want to, we can factor out the 1/3 times the absolute value of x and write this as 1/3 times the absolute value of x times the limit. Notice this is the given limit, which we know equals 1, and therefore our final limit is equal to 1/3 times the absolute value of x. From here, we know for convergence by the ratio test, the limit value must be less than 1, which gives us the inequality 1/3 times the absolute value of x less than 1. Solving for the absolute value of x, we have the absolute value of x is less than 3, which indicates the radius of convergence equals 3. This also indicates the series diverges when the absolute value of x is greater than 3. So again, to answer the question, the radius of convergence is 3, which means the series converges on the open interval from -3 to +3. However, for the interval of convergence, we would need to test the endpoints of x equals -3 and x equals +3 and determine if the series converges or not at these values. I hope you found this helpful.